The annual rainfall in a certain region is approximately normally distributed with a mean of 41.5 inches and standard deviation 5.5 inches. We are now working the third part to this problem, which is part C. What percentage of years will have an annual rainfall between 38 inches and 43 inches? So where to begin? Well, I like to draw my normal curve to start with to get a visual representation of what's going on. So I'll draw this normal curve. And at the normal curve, I'm going to label, again, my mean, which is 41.5 inches. That's 41.5 inches. And that's where my z-score is 0. And I know my standard deviation is 5.5 inches, so 5.5 inches away, which brings me over to 47 inches, right? 5.5 inches away is where z is equal to 1. So the difference between these two is 5.5 inches. That's where z is 1. I can also go the other direction where z is -1. And if I take 5.5 inches in the opposite direction, that tells me I'm at 36 inches over here on this side. So now I have a big idea, kind of a picture of what's going on, and I can address the question that's being asked. What percentage of years will have an annual rainfall between 38 inches and 43 inches? Well, I can visualize and see that 43 inches lies somewhere here on my graph, and 38 inches, well, that lies over here somewhere on this side of the graph. So I have a 43 inches and a 38 inches. And what I'm looking for is the percentage of years that falls in that band. In other words, I'm looking for the area right there under the curve, in between 38 inches and 43 inches. To address that, I'm going to have to look at two separate areas. I'm going to first look at the area of the band that's to the right of the mean, and then I'm also going to need to look at the area that's to the left of the mean. So let me start with that yellow band first. To calculate that area, I'm going to need to get the z-score that corresponds to the line where we have 43 inches. So my first job is to get that z-score. Once I get that z-score, then I can calculate the area. How do we go about getting that z-score? Well, we're going to set up a proportion. We are going to look at the proportionality between z equal 1 and 5.5 inches. In other words, 5.5 inches, our standard deviation, corresponds to the z value of 1. In a similar fashion, as the distance between 43 and 41.5 corresponds to this z value I'm trying to find. Now, what is that distance in there between 43 inches and the mean of 41.5 inches? If I take and subtract, I'll get 1.5 inches, right? Between 43 and 41.5, there's a difference of 1.5. So that band right there, that difference, 1.5 inches, corresponds to what z value in the same fashion as the 5.5 inches corresponds to the z value of 1. Solving this quick proportion, I'm going to cross multiply and divide, so that's going to give me 5.5z equals 1.5, or z is 1.5 divided by 5.5. And if we pull out a calculator and make that quick calculation, that tells us that 1.5 divided by 5.5 is approximately 0.272727 repeated. This is the z-score, 0.2727, etc., or approximately 0.27, that corresponds to the line at 43 inches. Now that I have that z-score, I can use my standard normal table and calculate the area under that normal curve. So at z equals 0.27, notice I'm at 0.27, And that puts me right here. 0.27 gives me an area of approximately, so the area corresponding right there to that yellow area is approximately 0.10642. All right, so that's the area on the right side in the yellow band. Now let's go to the left side in that blue band that I've highlighted. So again, we want to focus, this time we want to focus on this z-score. And to get that z-score, again, I'm going to set up a proportion. But this time I want to find this difference between 38 inches and 41.5 inches. The difference between 38 inches and 41.5 inches is actually 3.5 inches, right? So I'm going to set up my proportion again. 5.5 inches, the standard deviation, is to a z of 1 as, and now the difference between 38 and 41.5 is 3.5 inches, is to, and now I'm looking for this z-score, I'm just going to call it blue to correspond to that blue z-score, z. So now we're trying to figure out what this is. Again, a simple proportion, so we'll cross multiply and divide. That tells me that 5.5z is 3.5, or that z is 3.5 divided by 5.5. Pulling out our quick calculator, we take 3.5 divided by 5.5, and that gives us approximately 0.6363 repeated. Okay, 0.6363 repeated. Rounding gives me approximately 0.64. So the z value on the left side, corresponding to 38 inches, is about 0.64. And using that z value, I can again find the area under the curve by, slow down, Tina, slow down. Because I'm on the left side of the curve, my z value is actually negative 0.64. However, we don't have negative values in our chart, and so we use the symmetry involved with a normal curve, and we look for the positive 0.64. So I'm going down to 0.6 and over to the 0.04 column, so I get 0.64. So the area on this side right here is 0. So the area here, let me write this down, is approximately 0.23891. I now take that area and add it to the yellow area. And so the total then of those two combined areas is 0.23891 added to 0.10642. A little bit of quick math. Let's see. Make sure I don't make any mistakes here. Gives us the following. It gives us that the total area under the curve is approximately then 0.34533. I'm looking for a percent, and so I take my decimal 2 places to the right side, and that tells me that there is approximately 34.5% of the years will have an annual rainfall between 38 inches and 43 inches.